Hello now, engineers and piping enthusiasts. Welcome to another deep dive into the fascinating world of industrial piping systems. Today, we're talking about a cornerstone in the piping design world, the ASME B31.3 process piping code. This standard is a global benchmark for ensuring safety, reliability, and efficiency in process piping systems across various industries. In this video, we'll explore 1. What ASME B31.3 is and its scope. 2. Its key concepts and design considerations. 3. How it's applied in real-world projects. 4. Why it's essential for safety and compliance. Stay tuned, because by the end of this video, you'll have a solid understanding of how this code shapes the backbone of industrial systems. So, let's start with the basics. What exactly is ASME B31.3? ASME B31.3 is part of the ASME B31 code for pressure piping, a series of standards created by the American Society of Mechanical Engineers. This particular section focuses on process piping, which refers to piping systems that transport fluids, liquids, gases, or sometimes slurries used in manufacturing processes. These systems are essential in industries like oil and gas, transporting hydrocarbons through refineries, chemical plants, moving hazardous chemicals safely during production, pharmaceutical manufacturing, for processes requiring sterility and precision, food and beverage industry, handling ingredients in hygienic conditions. The code itself provides comprehensive guidelines for designing, fabricating, inspecting, and maintaining piping systems. It's not just about engineering, it's about ensuring safety, efficiency, and compliance with legal requirements. Now, let's dive into the scope of ASME B31.3. What exactly does it cover? 1. Design. The code outlines the requirements for choosing materials suitable for pressure, temperature, and chemical compatibility, calculating wall thickness to withstand internal and external pressure, defining allowances for corrosion or erosion. 2. Fabrication and installation. It specifies methods like welding, what processes and quality controls should be used, assembly, ensuring components like flanges, gaskets, and valves are installed correctly. 3. Examination and testing. The code mandates non-destructive examination, NDE, techniques like X-rays or ultrasonic testing to find flaws, pressure testing, hydrostatic or pneumatic testing to ensure the system can handle operational pressures safely. One important point: ASME B31.3 doesn't apply to all piping systems. It's specifically for process piping. Systems like water distribution, power piping, or heating and ventilation fall under other codes, like B31.1 for power piping or B31.9 for building services piping. Let's break down some key concepts from the code that every piping engineer should understand. 1. Design pressure and temperature. The maximum pressure and temperature a system is expected to handle determine the materials, thickness, and even the layout of the piping. 2. Allowable stress. This is the maximum stress a material can handle safely, considering factors like pressure, temperature, and material properties. 3. Fluid categories. The code classifies fluids into categories based on risk. Category D, low-risk fluids like water or air under mild conditions. Category M, highly hazardous fluids that pose a significant threat to health or safety. High-pressure piping. Systems operating above the code-defined pressure limits. Now let's discuss how ASME B31.3 is applied in projects. From design to testing, this standard is at the core of every stage. Design engineers. They use the code to calculate dimensions, select materials, and create layouts that meet safety standards. Fabricators. Welders and contractors follow the welding and assembly guidelines provided in the code. Inspectors. Third-party inspectors ensure compliance through rigorous testing and certification. Operators and maintenance teams. The code also helps plant owners establish maintenance protocols to keep systems safe and efficient over time. Finally, Why is ASME B31.3 so important? 1. Safety. Piping failures can lead to catastrophic accidents. By following the code, you minimize risks and protect lives. 2. Global standardization. It's recognized worldwide, making it essential for multinational projects. 3. Cost efficiency. Compliance reduces downtime and avoids costly failures or legal penalties. Simply put, ASME B31.3 ensures that piping systems meet the highest standards of reliability and safety. And that's a wrap. We've covered the scope, applications, and importance of ASME B31.3, Process Piping Code. If you want to dive deeper into specific topics like stress analysis, fluid categories, or case studies, let me know in the comments. And don't forget to like, subscribe, and turn on notifications so you won't miss our next video. Thanks for watching, and as always, keep learning, keep building, and I'll see you next time.